It did.
Cool.
Howdy. So does everyone have the paper link? I have.
Yes.
I don't. There you go. I guess I'll share it. So I wanted to talk about a little bit about this problem, the coherence problem. I think I have a decent-ish solution, but I don't like it over the longest term, and I wanted to get some feedback. And also Josh at one point sort of surprised me by expressing some dissatisfaction with the plan as I had previously expressed it, which I didn't know. So I thought it'd be a good thing for us to talk it over. I don't know how much to go over the background because I don't know how much people remember, but I'll just kind of go quickly through it.
Please do reiterate the background of what problem we're trying to solve and what the proposed solution is. I think it's worth a few minutes worth of exploration.
Yeah, that's what I figured. Okay, the bug is number 57893. And let me explain the problem via somewhat, before going into exactly the problem, I just want to explain like the model that leads to the problem. So we have DIN trait, of course. I guess we all know that the DIN trait represents some type that implements the trait, but the type isn't known. And usually it's kind of an object with a V table, right? And the interesting part is that in Rust, at least the way Mir and Ceph is set up today, virtual calls aren't actually directly expressed. It's more that there is a special impl that contains the virtual calls. So in other words, if you have like a DIN debug, then essentially the compiler generates an impl debug for DIN debug, which implements the trait for the DIN type. And the way that this implementation works is it has like a fat table going in that it can separate, fat pointer, that it can separate into a data and a V table, and then it can actually do the virtual call. But this kind of virtual call semantics isn't something that Mir knows about. It's more the codegens problem. That works nice. That has certain nice properties. But the problem is we're not supposed to allow people to write these kind of impls themselves. And if you try to write an impl this simple, you will get an error from the compiler. However, the reason we're not supposed to allow people to write it is because there would be an obvious coherence problem where the compiler is going to supply the impl, but now there's also a user-supplied impl, and we don't want two of them. Unfortunately, that check was just too simplistic. And it doesn't take into account at least impls of this kind. Just say an impl for all t where t is not sized. That also applies to a DIN type or code. But we sort of don't notice that. And what's more, we kind of rely on this in a pretty fundamental way as it happens. Most notably in the trait any, where we have a trait any, it has this function type ID, and then we have this impl of any for all t, and the idea being that you can always call type ID on anything, essentially, anything tick static at least, and you'll get back a type ID. But if you call that on a DIN any, you don't want the type ID of DIN any. You want the type ID of the hidden type behind the DIN. And if you just execute this impl, you'll get the type ID of t, where t is DIN any, so that's kind of not what you're interested in. You already knew you had a DIN any. So what actually happens in the compiler, though, is that there's a kind of ad hoc decision made. It comes along and it sees at least at code generation time, it knows that t is DIN any, and it sees sort of two potentially applicable impls. Either this impl that the user gave, or that we gave in the standard library, or the generated impl, and it arbitrarily chooses the generated one, which is the right thing for in this instance. It's what we want it to do, because we want to call through the V table. But it's okay in this case, but it's not always okay, right? So that's what I meant by the compiler resolves the ambiguity by choosing the DIN any impl. But some of my initial attempts, or some of the initial solutions we proposed, didn't handle this situation because we were basically saying, well, when we first discussed this, we said we'll just suppress the compiler-generated impl if there might be a user-given one, but that's not leading to the right behavior. That breaks the any trait. That's not really a good choice.
Is there
go on.
Just to get a rough idea here, is there any reason why it's possible to write your own impl t for dyn t? I can sort of understand why it's possible to write your own impl t for dyn u for some other trait u. Even then, that seems a little questionable as opposed to doing a blanket impl for things that implement u. But I'm curious why it's possible to write your own impl t for dyn t.
It's actually not possible in that syntax. The compiler will error. It's only possible to do it indirectly via blanket impl or something else.
Sorry, say that
Question
again.
mark sized specifically.
It's only possible if you do it via a blanket impl. It's not possible to actually write the text impl dyn, like, I'll show you. But you can't write something like.
Where are you typing?
I'm sharing, right? I'm typing into a playground that I think I'm sharing.
Okay. I thought you were typing into the paper document that you posted a link to.
No, but I can. But if you can see it, I'll paste it in the paper anyway. But if you try to just write impl foo for dyn foo, you get an error that says the object type automatically implements the trait foo.
Okay, that's good to know.
Yeah, someone's pasting good. But the point is that check is not bulletproof.
That's pasting something else, actually. That's the bug, not the thing you were just writing.
Okay.
How confident are we that the any is the only case where we're relying on the compiler's behavior here?
I went through every regression and categorized them. There were a few patterns. I couldn't find the document where I wrote those patterns up, which is annoying to me. But there were basically several cases where we were relying on it, but any was the only one where the change in behavior would be noticeable. There were other cases, they were like bridge cases where we say you implement one trait for all types that implement another trait and things like that. And in some cases, they might even wind up, in some cases, it might be that you would have called, basically any was the only case where the user written impl and the impl you wanted to actually run when you go through the vtable were not the same. In all the other cases, it seemed like they would have been the same impl, so you're two different routes to get there, but you would have wound up with the same code that I found. However, I would like to preserve the any behavior, so in a way it doesn't matter, but I don't think.
Right, no, the reason why I ask is more that you said that you've been rationalized as a form of specialization. I was curious, like where else we would need to apply specialization besides any. That's why I asked.
I see. I do have a list, which I'll try to find. I don't think I included it in here, of all the cases. And some of them, they're all pretty, the one thing I do remember is that none of them had any associated types, which I'm going to come to, which is important.
Do we actually generate the vtable implementation all the time, or do we actually only generate that if you ever use dyn foo?
I think we only do it when we do it upon demand. So whenever you coerce something to a dyn foo, we will make the vtable we need for that coercion, because it's going to be a different one for each such coercion.
Got it.
Okay. Right, so I was saying that, in fact, or where I would go from here is that, in fact, the current behavior is a kind of specialization. Essentially, there's a blanket impl that applies to everything, and a specialized one for dyn any. And if you had the default keyword, this would be just fine under specialization. And it would be sound even by the most strict rules that we have inside, like all the applicable rules, and come back to that. But, and this is essentially what the compiler is doing. Like there is a blanket impl, but we're ignoring it in favor of a more specific one that we generated ourselves.
The static here is not a problem.
The static here is not a problem. The reason it's not a problem in this particular case, problem. I don't think it is. I have to go back to what the rules are in any though. But if any had a tick static bound, which I think I was assuming it did, but I don't have it in this code,
Yes,
then
it
it's
does.
definitely not a problem.
It does.
Yeah, that's not easy.
Then it's definitely not. And even if it didn't, I think it would be okay, but it wouldn't be as obviously true. The key thing would be, does the specializing impl only apply when certain special lifetime bounds are met? And the answer is basically no. Anytime you can make it in any, this impl applies. Not for only some subset where they have a certain lifetime.
One other question here. Why is it that the solution is to have the equivalent of a specializing impl for dyne_any itself that does dynamic dispatch, rather than that we just don't generate an impl of any for the magic dyne traits, and instead they always pass through to the underlying object?
The problem is, well, if you think about code like generic code, let's see. So you could do something like this today. Can you see what I'm typing, Josh, or not? I'll put it in the paper.
I was going to say, where are you typing?
Okay. So if the question is why have a vtable impl, it's not really specific to any. I'm just using any as an example. But
It sounded like you were saying it was specific to any. That's why I'm asking.
no, what I'm saying is this is how everything works. Nothing I said is specific to any, except that if you just take away the compiler generated impl, you get the wrong behavior for any, whereas many other traits don't get the wrong behavior. And the reason
specifically wrong dynamic behavior, right?
Right. And the reason that you get the wrong dynamic behavior for any and not for the other cases has to do with essentially what the underlying impl is doing. So a lot of the cases will do something like, I don't know, I don't have it in front of me, but it's often a bridge where basically they implement one trait in terms of the other trait. And so in that case, the question would be, if you had a dyne that didn't come from that impl, then it would still be wrong. But it just happens that, from what I can tell you, always would. Like there are no other impls except for that one. I see. So the key thing about, I guess that's exactly it. The key thing about any that makes it different is that it's using this type ID intrinsic, which is basically reflecting on the type 2, as opposed to like invoking other methods.
You're breaking out.
Sorry. Well, I was saying the key thing, if you compare something like this, you might have like a, I don't know, you might have an impl that says, for anything that's right, I'm going to do my right. There are a lot of impls like these. These are not so much of a problem, even though this impl might apply to din my right. If you had like trait my right or something, then it wouldn't really be such a problem because it'll wind up calling right through the impl in the end of the day. But the problem with any is that what the actual any trait does, like this, the effect of this impl, or sorry, of this impl here, the actual any impl, depends on what t is statically thought to be. So you could make other cases that would break through specialization or other means, I guess.
So you're saying that if the object is statically thought to be a dynamic trait object, if I'm understanding what you mean by that correctly, then any would give the trait object's type ID and not the underlying object's type ID?
Yeah. I think this would apply to anything that used some way of inspecting what the types are.
I think that's what I'm asking. Why do the generated dynamic dispatch-based trait impls have a type ID rather than always passing through to the underlying type ID?
I mean, they don't, because of the, like, it's hard to answer this question because there's so many possibilities, but the idea is with the compiler today, they kind of don't because of this specialization trick. Like, we specialize them to say, so all types have potentially a type ID. You can't easily observe the type ID of din any, because when your type is din any, we go through the vtable instead and you get the underlying type.
Well, yeah, I think, Josh, the key thing is that din any is a type. Like, so if you use the direct type ID of API and it passed, like where the cursor is on the paper on the screen, if you pass din any in there, you'll get an ID back because din any is a type, and so it has a type ID. And like, so an impl that applies to any type will necessarily applies to din any because din any is a type.
One way to look at it might be your type. Like, one way it has to work, one reason it has to work that way is T here might not be din any, it might be box of din any, say. Like, that is a type, and so the type ID needs to be able to like recursively deal with that. So it does.
Just to confirm, the type ID of box din any should be box din any and not any, right?
That's right. But the point is, it's boxed in any and has nothing to do with the underlying type that boxed din any is hiding.
Right. No, but that seems perfectly fine.
It is fine. I'm just saying that you have to be able to get the type ID. Like, box gets its type ID by recursively getting the type ID of its argument, which is din any, and in that case, that's what we actually want. The only case where we don't want to go through the vtable there. So we want the ability to get a type ID for din any, just that we don't want to be using it when you call methods through the any trait itself.
I see. That was the question I was trying to find out, was why it is that in general din t needs a type ID that is not the type ID of t.
Right.
And it sounds like the reason is that in any other case where we are stuffing a din t into a box or an RC or any number of other places, in any of those cases, we actually do want a distinct type ID for it. We just don't want that type ID to cause breakage in the one very specific case of din any.
Right. Sometimes you want to say, sometimes you want to say, well, what I have is a trait object. That's the thing I'm trying to downcast to, essentially.
I see.
So, right.
Sorry, no, you should continue. But there's a problem with making this simple default.
What is it?
Well, so there's recently been a discussion over whether the any trait needs to be unsafe.
Okay.
Because if you can specialize this and create a specialized symbol for any, you could, pass any type ID you want in the specialization.
Let's note that for later, but I think that's it.
Is that just an argument that you shouldn't be able to implement any yourself, period?
Well, right now you can't because the impl is not specializable. So right now because there's an impl for all types, you cannot provide. But if we make it specializable, then we need unsafety. And so this will interact. Right.
Unsafe, or alternatively, we just need to say, if you're not the compiler, you can't implement it.
There was some proposals. We can come back to that, but I think it's a good point and also a more general problem of specialization, right? And there were some proposals to like let you say it's default, but only within this crate and things like that. Which would it be what?
I got a bit curious before when you said when you talked about Mir not representing virtual calls directly. I'm aware that's the case, but I was just wondering why that is the case. Maybe that's not super relevant to this discussion.
It's definitely relevant. There was an earlier, I mean, we had an earlier round of DIN trait design settled on that approach. It's not a necessary approach. Let's circle back to it, because I think it's relevant if we're talking about what we want to do long term in terms of how we want to.
Presumably, we still need the logic to generate these DIN trait impls of a trait if we're ever passing, for example, DIN right to something that expects some static right type.
Yeah, I mean, we would.
The difference is that we would, in that case, we would only need to generate it if you pass a dyne right to a thing that wants some W where W implements right, as opposed to having to generate it at the moment where you have a thing of type DIN right.
You kind of need to generate it the same, but let's come back to it. I just want to go one last step and just say why this, just to close we haven't actually got to the soundness hole yet. But okay. The soundness hole basically is, for any, there's not really a problem, and it's precisely because you can't really observe the types of methods right now. So adding a default doesn't affect any code except for what happens when you call the method. But if you have associated types, that's not really true. And
constants with const generics would be the same as well.
Right. Other kinds of items, you can sort of start to see the difference. And that's exactly this is the bug that Central's weaponization of this problem. It relies on having, this is the impl that Central wrote, or it's in the bug, the user provided impl, where the type output is U. But in the version that the compiler would generate, there wouldn't necessarily be a connection between this type U and the output. And you can kind of leverage this, combined with the specialization, the fact that we implicitly choose the compiler generated one whenever we can, to get things confused. And if this version had the word default here, if this were a legal specialization, if you would have been forced to write it as a user, we wouldn't have this problem, because the compiler would know that it can't rely on this associated type. It knows that it's potentially specialized.
Sorry, if it had the word default where?
In the user supplied input, impl, basically. The idea of specialization is you're supposed to write default on things that might get overridden. And the thing I'm arguing here is the bug is the compiler doesn't realize this might get overridden in some sense. And if you didn't declare default, you wouldn't have this code. This code wouldn't compile.
Are you assuming the new associated defaults RFC here?
I don't think that makes any difference.
Okay.
Because I could be mistaken, but I think that sort of tells you what might happen if you didn't write any associated type at all or whatever. But either way, sort of that kind of desugars down to either the value is fixed and can't be modified by a specializing impl, or it's known to be overridable, default in other words. And the point is, because we're generating the specialized impl, we either need it to be overridable or we need to reject this sort of impl, I guess. I don't think we can reject this sort of impl offhand, because it applies, well, we'll come to that later. Does that make sense so far? Why the default would fix this? I think I even tested that, but I don't see a link to a playground right now.
I don't think it makes that clear, no.
The premise of the compiler needs to know when an associated type might change, might be specialized, I guess, is the core point. Otherwise, it will assume that it knows what the value of that type is, and that might be wrong.
Sorry, I should clarify. I understand what the default keyword tells the compiler, that this might be overridden. I think I'm failing to understand what the problem is and why telling the compiler that fixes it.
Okay, so the problem is this. Suppose that I'll just say it in the general case first. Suppose you have two impls, Like this one is out, is object or something. I'm going to simplify it not for din trait just for a second though. Let's do this. Okay, can you see in the paper, Josh?
Yeah, I can.
So if you don't have, this is illegal without the keyword default, first of all, but
Right, because T is a blanket impl, so it's covering U32.
Right.
Uh,
So now I'm writing a generic function, and all I know is that T is some object, right? Let me change this to a different letter so that it's not so confusing.
Okay, that
So now
helps.
the
Thank you.
question is, what do I know about T output? Based on what I see in this function, and actually one other thing I want to change this slightly. Downstream crate, just to make it even clearer. Suppose there's some other crate.
Oh, I see. You are, because it's default, you are not allowed to assume what the projection is equal to.
Exactly. So if you know, here in this, there's two different crates, right? And in the upstream crate, I only have one impl. So in some sense, in before specialization, it would be reasonable of me to say that the T output must equal unit because there's only one impl and it applies.
I'm not, how is that correct even without specialization? You still don't get to know what that type is because you specifically asked for T object.
Well, the point is, I don't even need to know the T object because this impl alone tells me everything I need to know. Because the impl tells me that this impl applies to all types. And so whatever T is, this impl must be the one that it came from.
T is sized, no, T is sized, so...
Yeah, technically there's a size bound, but it's in both cases, so.
Yeah.
Okay. But in the presence of specialization, you don't get to assume anything about T output, right?
Right, and that's why we require you to write default if you might specialize it, because now the compiler knows, there might be a specializing impl. So even though I know that this impl applies, I don't know that there's not a better one that changes this value, so I can't.
Okay.
I can't.
So without default, the compiler will let you just assume that T output is unit.
Right.
But with specialization and with the keyword default there, then the compiler will just say, you don't know what T output is, it's T output.
Yep. This should also work perfectly with constants as well.
Yes, and it's actually required, this design is sort of required by backwards compatibility because existing code wants to assume that it knows its unit.
So hypothetically, if we stabilize specialization, some future edition might choose to say types are always specializable and you never get to make this assumption. Hypothetically, I'm not saying we want to do that. I'm saying the only reason we don't do that for now is backward compatibility.
That is one reason we don't do it for now. Yeah, you would need an addition.
A reason we don't do it now is backward compatibility.
The main thing is you need to know, you could pick either default with an addition translation, but you do need to know if it's specializable or not.
Okay.
So the problem, right, so that's the kind of premise here. And now the main thing is that we have the same scenario, but we don't have the keyword default. We're just allowing this specialization to happen when it shouldn't have. Okay.
Okay, that made a lot more sense about, in general, what kind of problem not having default can cause, and what assumption can apply.
So, let's see. The next thing I had in here was RFC 2027. No, it's not that. So this was a change that Bodes proposed that called object safe for dispatch, that basically the main thing is it changes. Right now you can't even use, it's kind of a red herring. I'm not gonna go too deep here, but it's somehow relevant. you can't use a DIN type today unless the trait is considered DIN safe. However, under this RFC, you can use the DIN type. You just can't make instances of that type, and you don't know that DIN foo implements foo. So this is relevant if we start changing the rules for what DIN safe means to take into account some of these different proposals and so on. But
by the way, I am so happy we introduced Dyn.
it's a really useful word. Yeah, it makes it easier to talk about these things. So interaction, multi-trait, oh, right. Just one minor point is to keep in mind, all my examples I've been saying DIN with one trait, but we would like to generalize in the future, and we already do in certain cases, to support DIN A plus B plus C, which just makes it a little bit extra fun. I don't think it changes anything too fundamental here though. But importantly, the compiler doesn't just generate one impl necessarily, it actually generates a family of impls. So like, if you go in this more generalized form, so like you have impl trait for DIN trait, as I said, but you would also have impl trait for DIN trait plus X, where X is some set of other traits. Those are kind of distinct things that we have to keep that in mind. So how can we fix this? Well, one thing we can do that I haven't actually tried, but I think would work based on what I did try, is to say that do I think this would work? Actually, I'm not 100%. I just realized that my test didn't prove what I thought it did. But the first thing we can do is we can identify what I'm calling potentially DIN overlapping impls. They're basically impls implemented for some type parameter that might not be sized, because those are the ones that might also apply to a DIN type. I realize this is not entirely complete. It should probably include or the self type is actually a DIN type. But anyway. And what I was going to propose is that essentially, if the trait is DIN safe, and you have a potentially DIN overlapping impl, then we consider the members to be default. This would have no effect on any, because any only has functions. It would have an effect on the example in question, because that one has, it basically only affects things with associated types. But it affects all, the problem is it affects all DIN safe traits with associated types, whether or not they are used as DIN values. And that's not great.
Well, so just to clarify, you said it wouldn't affect any, but it says all items are considered default, so it wouldn't make, I would think that the function item, the function method in any is itself
right.
an item.
It wouldn't affect any, it just wouldn't make any code stop compiling or change semantics.
So the reason that this is potentially Dyn overlapping is that the Dyn T object is a trait object type that is not sized. So if you're doing a sufficiently blanket impl that it is blanket even over things that aren't sized, then it potentially applies to a Dyn foo.
Yeah, I think I copied and pasted the wrong impl here. Also, this is the compiler generated impl. The impl that I wanted to have was this one.
It seems quite nice that the proposal is a simple syntactic check.
I think that's necessary also, or close to it, because otherwise, if it requires complex logic in the trait system, then it starts to get into cycle problems, which is one of the first.
Yeah, and the soundness gets much harder to verify.
So, Josh, are you seeing my screen now? This is the impl that it would affect.
So I can only use Zoom on my phone, so I'm seeing your screen where each line of text is about 1 millimeter high.
Okay, I'll put it in the paper. So, I really should. I had hoped to have a. I did. I had hoped that I would be able to test this, but I didn't get to it.
How feasible would it be to make things default but not actually specializable unless the default keyword was like to have a.
Yeah, I was going to come to that. I down here somewhere, I was kind of going through some of the implications of this. I mentioned that I would probably want to say that so long as the user has not written default, I wouldn't just act as if it were default. I have a subcategory of like compiler.
It's default only for the compiler, yeah.
Yeah, and it could not actually be specializable for the short term. If that's something we want to express long term, we should talk about it. Like this is sort of a hokey, but I do feel like I guess I was thinking that if we wanted to, however we want to go about this, ideally we would guide users to like write default explicitly. But now you've given a good reason why, beyond the fact that it's not stable, why they might not want to, unless there was a more expressive option. But I think that's an orthogonal concern, but it's still important.
I mean, I wouldn't want like people to not realize that they have created a specializable impl that could be specialized.
That would be particularly bad.
Yeah. So did I accurately capture your suggestion, Boat?
I think that's right.
Yeah.
I don't think that's very hard to do. It's just.
I
think that's a very sensible thing. We're inferring the compiler internal property that default also enables don't assume this implementation, but we're not also enabling the property of you may specialize this.
Yeah, I think that because default has sort of two meanings, right? It has its meaning in relationship to like instantiation, where it means that we don't actually know if this is
you get opaque.
And it also has the meaning in terms of allowing specialization. I think we should treat those as separate concepts for this.
I like the, well, anyway, I personally like the idea of being able to say default crate or some other visibility level.
Sure.
But I feel you could imagine even within a crate wanting to say like, like privately default within this module. Like,
that's very interesting. I
do
like the idea of being able to like now restrict like how the level of breaking parametricity.
Yeah, but I think that we should we don't even need to do I think that the semantics for this case should be that it's not specializable even if we didn't generalize to having this feature.
I agree.
Yeah, it's a very nice generalized feature, and I do think there are many people who would like default crate. For that matter, there are things within the standard library that should perhaps be written as default crate if we use specialization.
Right.
What we typically do in the standard library is to make a new private trait, and then we negotiate the specialization.
That's what I mean, but we could potentially drop that private trait and just make the public trait default crate.
So,
that would be useful.
About this.
Let's focus on the science issue, less on the language features.
My only question about, I definitely would agree that this property should be maintained. The only question I had was and what I hope we might discuss a little bit, is where are we going on what time frame? I'm not crazy about, I think this is assuming that we try it and it doesn't break a lot of crates, I think it's a reasonable soundness fix to say that we implicitly assume default here. But if we had designed it from the beginning, I think we wouldn't have done that. We would have requested people to write it explicitly or something. I would sort of like to get to, I would like to get to somewhere where we are happier with the end result, whether that's a new addition or not, I don't know. And in other words, I would prefer that we warn people about the fact that it's default, actually, but we can't warn it. I don't think we can warn them unless we have a way for them to change the code so that they don't get warnings.
Well, one way for them to change the code would be for them to be able to write default self, or perhaps something that is more clear about what property that they are writing there. One other approach that I'm curious about have we done a crater run to find out how much would break if we just said default or no default, you're not allowed to assume an associated type unless you have a concrete type?
Tons of stuff, tons. I don't need to do a crater run to tell you that.
Okay, I mean, can you give me a random example of a case where we do require that you need to know what the specialized type is without knowing what your type is?
Yep.
What the associated type is, rather, without knowing your type.
Right. So imagine you have a vec of t,
right?
and you would like to know, you want to write, you make an iterator over it. Let's
Yes.
just have an iterator, a vec iter of t. You could have specialized, you might like to know what the item type is of that iterator when you call. You would like to know you're going to get a t when you call x.next, but or an option t, I guess. But that actually requires resolving an associated type, and it's potentially the case that someone might have specialized the implementation of iter for a vec of a specific type, and altered that output type if we didn't have some rule that prevented them from doing that. So, like you could write, you see what I'm saying?
That's just an argument that the type needs to remain fixed. It's not an argument that you need to know what the type is, right?
Well, both are obviously true. I mean, if you know the type is not going to change, then you first of all.
I was going to say one aspect of that is you just wrote that X is a vec iter, which you know what type vec iter is. Do you mean it's an impl iterator?
No, but you don't know the full type. You only know that it's a vec iter of some t, but you don't know what t is. And so it's possible that there's like a specialization of vec iter for some other type. That's kind of one of the prime use cases of specialization, actually, is that you write generic things. But this is illegal. We don't have this problem because this is illegal without default item equals t.
But
and the principle has equally to like.
it would be good to like fix the Thomas hole without waiting until specialization is stable and stuff.
Right. I don't think we have to. I mean, if we treat it as default, we're not making anything stable beyond like horrible kind of complex rule that says in this kind of case we will not resolve these associated types. Stably observable behavior.
But we need to have that behavior for soundness, basically.
Right. I mean,
so,
I'm saying if we made this soundness fix that I proposed stable without stabilizing anything else, that would be a user observable effect.
Yeah.
So for the sake of completeness and just understanding how often this comes up, if we were designing this from scratch, or if we had a new edition in which we could treat this as not backward compatible, would it make sense to have default be the default and to add some keyword that means you're not allowed to change this in a specialization?
Analogous to like final in Java, maybe?
I mean,
I don't think I'd quite use that because that means something very different. But I mean, in this case, having a keyword to say you get to know that this is this type without having to check for specializations, and then specializations can't change that type.
I think the answer is probably no, because of cases like I think if you look, you'll find that there's a great many cases where you don't know the full type. You only know enough of the type to know. Like this vec iter example, I think it would be quite unnatural if I had to write final type item here, but it's a little hard to say. In any case, I think the scope is so large that we probably wouldn't do it.
The associated type in defaults RFC goes in the opposite direction, where it's not definitely not specializable unless you write defaults.
Also worth noting that OO languages themselves have moved in that direction. Like in Java, at least the last time I wrote Java, which was admittedly a while ago, people were encouraged to write at override on methods and things like that to kind of indicate,
Yeah.
make it clearer what's happening.
I think it's interesting that both this soundness and the pin soundness, the solutions are like trait system features from 2015.
I know.
I don't. Yeah, I don't know what that says, but.
But okay, we're about to run out of time, so maybe we don't want to go too deep. The thing I was, the whole, or not the whole, but one of the motivators for this meeting, I think it's good we had time to go into depth, was my sense that, okay, so first of all, next steps. I think I should try this soundness fix. I don't think it's too hard to implement. I don't know. I thought that I could say with confidence that it wasn't going to have a lot of impact based on the cases I looked at, but I realize now that's not necessarily correct, because what I looked at was making things not, let me clarify. So what I did was, if I remember, I said that a trait is not DIN safe if it has a potentially DIN overlapping impl. So that made things into errors where people were relying on these impls. And I had a rusty DIN attribute you could use to opt back in, so I could fix the standard library because, and then I looked at all the cases, but I realize now there might have been cases where you have, if you apply this soundness fix, there might have been cases where you have a trait that is DIN safe, but was never used as a DIN value, and I didn't consider that, and that might break. So if I had like my trait, you know, and I impl my trait for this would be
checking
DIN.
whether it is used as a DIN value seems like it would severely break separate compilation.
Yeah, so this would become, under my proposal, default type T equals U, and thus there might be some code that breaks. And now that I think about it, it might even be a lot. I don't know. We'll have to see. It doesn't seem that unusual, though. So what I,
but
regardless
just
whether
you could test this and find out what breaks, right?
That's right, I can test it. But what I was going to say is, regardless of what breaks, it's not a design I particularly love, because that nobody asked to be DIN safe in this example. Yeah. We just decided you were DIN safe, so you get this extra restriction that turns out breaks you, or, you know, that you might not want. So I think if I were designing this from scratch, I would have preferred a way to say I want to be DIN safe, and thus I accept the restrictions that come with it. And I think that's true just in general. I kind of regret that side of Rust's design.
I think DIN traits who would be nice, but I think we should also like fix the short-term problem first, and then focus on that first.
Well, I agree we should do that. I would like to try the fix and see what the impact is, and if it's too big, maybe there's a way. I should think there are probably ways to tweak it. But
to be clear, what Central's referring to there is the explicit opt-in that's in the paper, right? I want the flow here is we jumped ahead a tiny bit, I think, without writing down the proposed explicit declaration DIN trait foo or my trait here.
Yeah, so that's where, well, that's sort of, that was the reasoning exactly that brought me to the idea of maybe I should, it would be nice if you had an opt-in syntax to DIN safe. And there's some advantages to that, both conceptual in my mind and like practical, in that it cuts cycles and stuff. So you don't no longer have to you don't have to figure out if it's DIN safe. The user is just telling you, and you can use that fact in your rules and then separately enforce the requirements.
So presumably if you explicitly opt into, leaving aside the question of if we want this to be opt-in, if we made it opt-in, then we would no longer need to infer you must declare this default. We could instead say you must declare this default and make it an error.
Yes, we would do that, yeah.
On the new edition, presumably.
No, anytime you write DIN.
Right.
Right, but for
on older
old
edition,
code.
wouldn't require that you write dyn, and you would still implicitly opt in. But if you explicitly opt in, then you're explicitly opting into the restriction, which means we don't need to infer default, you have to write default. At that point, by the way, we might very much want to add the default self mechanism or some other way of saying, but I don't actually want people to be able to specialize this.
Yeah, and so one of the reasons I wanted to bring this up now is that if we did plan to do something like this, I think the time to be thinking about addition changes is now, in short.
Yeah.
So that's why I'm bringing it up, even though I do agree we should deal with the soundness fix. You know, we can handle both at the same time, and they should. But if it's not this change, I'm not sure what is the.
Sure.
I think there might be other.
So I have a few points here. I think it would be a good idea for Ariel to view the actual pull requests and make sure that you like cover all the ways you found to break mine and Valve's initial ideas for fixing things.
I think that would be good. I would like Ariel's feedback. Yeah.
Right.
And if you can just check the associated type defaults RC as well to make sure there should be, but just to double check, that would be great.
So to bring up the thing that Nico hinted at the start of this meeting, so I think the soundness fix seems reasonable. It certainly makes an interesting corner of the type system a little bit more arcane to explain to people. But that aside, it seems like it fixes the problem. The proposal for Rust 2021 to require that you opt into DIN-safe explicitly, I feel like that would have a negative effect on the Rust ecosystem for the specific reason that it means people will not write DIN trait by default, especially if, kind of like me, when they first got started, they were like, ew, dynamic dispatch, why would I ever want that? And then somebody comes along and asks for it, and first the crate maintainer has to be convinced that dynamic dispatch is not this horrible thing that you should rewrite your code to avoid. And then second of all, they have to actually add it and add the ability for people to opt in. And then they have to understand dyn to the point of what am I opting into exactly here?
So it's
All
like
so that somebody can flexibly write code that uses dynamic dispatch, which is a feature of Rust.
it's sort of like debug but worse, because dynamic dispatch has this maybe unfair.
Yeah, it's very much, could you please impl display or could you please impl debug, except instead of, oh, of course, that makes perfect sense. It's, okay, first let me understand the type system. Give me 3 months.
Yeah,
Yeah, that seems like a good thing.
Although I think it goes also the other way, that there is today an implicit semver problem that people don't realize what they're backing into. There was.
Is that such a problem though? In practice?
I don't know. Yeah, it's a good question. I did find one interesting example of DIN borrow. This is used in practice. I think you could use this to argue maybe either way, in that I don't think anyone meant, the borrow trait is like this little transient trait that's used on hash table methods. I don't think it was like designed to be DIN safe or anything. On the other hand,
maybe we want like undyn traits.
Yeah, I would actually go that far as to say I would be all for having an opt-out for DIN safe, so that you can say, even if I look DIN safe, I don't actually want to be DIN'd.
Like static traits.
Like that seems so. Actually, I think that whichever make the thing to opt into is actually the one that there's going to be pressure to do, because if like you have to say static to say, then you're like, basically, because my impression of the way that people use Rust is they like to add all the annotations that would make their thing as good as possible. And so the attitude I feel would be you should mark a trait static unless you intend them to be used for dying traits, because that will make you more semver compatible if you ever want to add something that would be not object safe in the future. Whereas if it's din, the attitude would be you should mark your traits din if they are dying safe, because then like I guess I understand. I just would dispute that one is more stigmatizing than the other. I think that like the culture could work out either way.
It's a reasonable claim. I don't know which one it would be. I certainly know what would make sense to me when I was first getting started in Rust, and it's much less add all the things and much more, if I don't understand that, I'm not going to add it.
I personally feel, well, knowing myself, of course, I'm not the average user, but like I would err on the more lazy side, typing less.
I think the backwards compatibility is also a consideration, but
Yeah.
like if we don't have to migrate the ecosystem in a way that people notice, I'm happy. We have the ability to do so, but not the obligation.
Well, we still have. I mean, the inferable thing is still necessary for to not break things existing code. So.
Right. I'm just talking about like I'm just saying if we were going to add either din or static trait is one that doesn't require an addition.
I was going to say that is one other advantage there is you could you can opt out of din safety and not change the current default.
Although, yeah, it does raise the question of like, should you be using it if you, like, if your tree is not din safe, should you say so? Or let the compiler just figure it out. But
like the things that aren't din safe, wouldn't we want to start warning people that didn't mark them static if like they already have a like?
Yeah, exactly. Then it'd be a different thing.
Otherwise, what's the point?
Sorry, say that again.
Like traits that aren't din safe today, like wouldn't we want a lint to tell people they should be marking them static so that it's documented that they're not din safe? You know, like,
sure.
But that's gonna it's also gonna be churn even if it's not like an addition change. Is what I'm saying.
I see. So we'd want a lint in 2018, and then 2021 could say if you're not din safe, you should have to say so.
I don't know. I just think. Well, I guess I think that it's hard to say which of these is like. I think we should have like a larger conversation with the community to figure out.
Yeah, we're sort of in the weeds now and over time. I think, and we probably are better off trying to do some research on this question of which one happens in practice. Do people tend to add annotations or not?
Yeah.
That's anecdotal.
And just in general, like how much do people think
it's different for different people, probably.
So I agree we're over time. I'd like to end it because I have to go get lunch. But some questions for thought. I think one of the questions would be like, how bad is the dying trait member interaction? Like how often have people, like traits don't evolve that much anyway, in some sense. Maybe it doesn't happen that often that people break.
Well,
another question.
I do have a hard out, so I'm going to go. Bye.
The iterator traits evolve quite frequently, but in a semver compatible way.
Right. Well, I mean, the standard library obviously makes sure that it's.
Okay. All right, thanks you all.
Thanks.
We're going to call it.
Yes.